Hello and welcome back everyone. Today is the final video in our numerical computing series and we are going to be finishing that off by learning the Gauss-Jordan elimination method. So without further ado, let's get right into it. Okay, so what did we learn in our Gaussian elimination method? Well, we learned that there should be a diagonal in our augmented matrix and each of the values in that diagonal should be equal to 1. The values below the diagonal should be equal to 0 and the values above, we don't really care about those. In the Gauss-Jordan elimination method, we do care about the values above the diagonal, sort of like here. So we are to create a diagonal by using the row operations, and we are to find out x, y, and z. Finding out x, y, and z becomes easier in the Gauss-Jordan elimination method because we don't have to do anything else except simplify the augmented matrix by using row operations. So let's just get right into it and we will learn along the way. Okay, so here we have 3 equations with 3 unknown variables, x, y, and z. First of all, let's create an augmented matrix. Okay, so here we have 1x is 1, 2y is 2, minus z is minus 1, and 1 is 1. The same thing goes here. 2x is 2, 5y is 5, minus z is minus 1, and 3 remains 3. 1x is 1, 3y is 3, 2z is 2, and 6 remains 6. Alright, let's get on with our row operations. In column number 1, we need the values 1, 0, and 0. Do we have those values here? No, we have 1, 2, and 1. So we need to make this 2 and this 1 equal to 0. How do we do that? Row 2 minus 2 multiplied by row 1, and for the third row we could do row number 3 minus row number 1. Let's see what does that give us. Okay, the operation being performed on row number 2 is R2 minus 2 into R1, means the value of R2 minus 2 times the value of R1. Let's get on with it. Okay, so 2 minus 2 times 1, that is 0. 5 minus 2 times 2, what is that? 1. Minus 1 minus 2 times minus 1, that's doozy. That gives us 1. Right. Now, here, what is 3 minus 2 into 1? 1. Easy. Let's do the operation on row number 3. What operation was being performed on row number 3? Yes, the value of row number 3 minus the value of row number 1. So, 1 minus 1, 0. 3 minus 2, 1. Okay, let's move on to column number 2. Alright, so what values do we need in column number 2? We need 0, 1, and 0. Right. Do we have those values yet? No, we have 2, 1, and 1. Luckily for us, we already have a 1 in row number 2, so we do not have to touch row number 2 whatsoever. We just need to carry out our operations on row number 1 and row number 3. So, what could we do with row number 1? Well, let's do that exactly right now. Okay, so we could do row number 1 minus 2 into row number 2. Right, and on row number 3, we could perform the operation row number 3 minus row number 2. Okay, 1 minus 2 into 0, that is 1, obviously. 2 minus 2 into 1, what is that? 0. 1 minus 2 into 1, what is that? Let's try that again. 3, 2, 1, begin. Minus 1 minus 2 into 1. Three, 2, 1, begin. That gives us minus 3. Oops. That gives us minus 3. And here we have 1 minus 2 into 1. What is that? Easy. That's minus 1. Let's check on row number 3. What is 0 minus 0? That's 0. What is 1 minus 1? That is 0 still. What is 3 minus 1? That's 2. Okay. Here. Now, What is 5 minus 1? Yes, that's correct. That's 4. Now, let's take a look at what we have here. Column number 1 is complete. 1, 0 and 0. Column number 2 is also complete. 0, 1 and 0. Now in column number 3 we need 0, 0 and 1. We have neither of those values. So what could we do which could help us get those values? Okay, so we could divide row number 3 by 2. What would that yield us? Well, let's take a look at it for ourselves. Row number 3 divided by 2. 0 divided by 2, 0. 0 divided by 2 again, 0. 2 divided by 2, 1. 4 divided by 2, that is 2. Okay, so now let's check column number 3 again. Do we have 0, 0, 1? No, we have -3, 1 and 1. But the good news is we have the 1 in row number 3. Now we could use that row number 3 to carry out operations on row number 2 and row number 1. So let's just do that exactly. So what we could do on row number 1 is 3 into row number 3 plus row number 1. On row number 2, we could perform minus row 3 plus row 2. That could give us a good answer. Alright, so let's calculate row number 2 and row number 3. Okay, 3 into 0 plus 1, that's 1. Okay, 0 into 0, I'm sorry, 3, 2, 1, wait. 3 into 0 plus 1, well, 1. 3 into 0 plus 0, 0. 3 into 1 plus minus 3, that gives us 0 again. Okay, now we have here 3 into 2 plus minus 1, that gives us 5. Lovely. Let's check row number 2 now. Minus 0 plus 0, 0. Minus 0 plus 1, that's 1 still. Okay, minus 1 plus 1, that's 0 again. And minus 2 plus 1, that is minus 1. Okay, so here we have our augmented matrix simplified and completed. What we have here is a diagonal and all of its values equal to 1. The values below the diagonal equal to 0 and the values above the diagonal equal to 0 as well. So now we can find x, y and z. How can we do that? Well, let's check. Alright, so we can do, what is the first row? It's 1, 0, 0, 5. So it could be translated into an equation which could be 1x is equals to 5. Okay, let's check row number 2. What is that? 0, 1, 0 and minus 1. So what could that translate to as an equation? That's right, 1y is equals to minus 1. Let's check row number 3 now. What are its values? 0, 0, 1, 2. What we could conclude from that is 1z equals to 2. Therefore, the values of x, y and z are 5, minus 1 and 2 respectively. I hope you guys enjoyed the video and learned the Gauss-Jordan elimination method correctly, and hopefully it may help you in the future. Thank you so much for watching. See you in the next one.